Behind me, we have Bluetti's new big thing, the AC500 solar generator. I do mean big. At 80 plus pounds per battery and nearly 80 pounds for the AC500 control head itself, it is a beast. It has 5,000 watts of AC output, 800 plus watts of DC output, 50 amps or 6,000 watts of AC charging at maximum. That's assuming you have the right plugs. 3,000 watts of DC charging from the built-in solar controllers, and that's not including that you can add more solar panels directly to the batteries. It can control up to 4 B300 batteries or up to 6 of the new B300S batteries, giving you a little bit over 16 kilowatt hours of battery storage total. Tonight we will take a look at it, run a few tests, poke through the menus and features, and hopefully determine if it's worth spending any money on. Before we get into it, I want to call out that this is a reviews unit that was sent to me by Bluetti. I'm not paid to make these reviews, nor does Bluetti have any control over the content. I make my money elsewhere, and my work with solar generators is purely a hobby. The review unit here goes back to Bluetti as soon as the test is over. Let's take a look at some of the connectors on Bluetti's AC500. So first off, we have 4 output power plugs. We have 3 covered by rubber grommets, 20 amp, regular NEMA house plugs. We additionally have a 30 amp output twist lock is what they're called sometimes. This is an L430 connector. We also have a 3-prong. This is a TT30 connector, same as is on the AC200 Max. And this is a 50 amp connector. Here is a 10-4 STW connector, commonly used for RVs. Now, the twist lock connector and the 50 amp connector, so the 30 amp here and the 50 amp here, can be either 120 volt or 240 volt connectors, depending on how many legs are energized. In the case of this is only one of the 2 legs are energized, so you're not going to get split phase power out of one AC500. You'll need 2 of them for that. What else do we have up here? We have a 12 volt 30 amp connector, same as is used on the AC200 Max and the AC300. You can get 30 amps at 12 volts out of this. The cigarette lighter plug is 24 volts DC. Be careful about that. If you plug your 12 volt stuff into it, you might have trouble. But if you've got a 24 volt fridge, that's really what this is for. This will run your 24 volt fridge with much higher efficiency than a 12 volt output would. We have 2 100 watt USB-C. These are output only ports. We have 1 18 watt quick charge port, 2 of them, and 1 set of USB-A, 2 of them, 5 volt 3 amp connectors. On the battery itself, we have 2 more USB ports. One of them is USB-C 100 watts. The next one is USB-A quick charge. We also have a 12 volt 10 amp cigarette lighter port on the battery itself. The battery, just like the other Bluetti devices, works fine without the main inverter, but then you're limited to the outputs on the battery itself. Let's take a look at the side connectors next. We have a number of connectors on the sides. So the top one, these are screw-off lids here. We've got the AC input. That's a 3-prong. Again, the same connector as the AC300. We've got the 3 connector here, airline tile style port, and if you need to know what it is, it's a Weepoo's SP29. And we've got the standard house plug on the other side. Next down, we've got the input for the solar. Right here, we've got 4 prongs, and again, it is the same connector as is used on the AC300. Connectors right here. We've got 2 sets of PV inputs, A and B, and then we've got the connection on the other side. Next, we have the communications port cable. Again, the same as the AC300. This is if you're linking 2 of them together for split phase mode. Next, we have 2 battery input ports. One and two battery input ports. This uses their new 150 amp connector that, by the way, is different from the connector on the AC300. So this port does not fit into your AC200 Max or your AC300. It's a different connector. The manual does call out that they will be releasing a conversion connector. Pull that up real quick. The conversion connector will allow you to plug the old batteries into the new solar generator so that you can use the B300 batteries, if you already have a bunch of them, and just upgrade the head unit to the larger head unit. So we've got two of the battery connectors. On the battery itself, we've got, again, two more battery connectors, just like the B300. We've got a power adapter, again, just like the B300. Takes the T500 power adapter. And we've got the DC input port, this time limited to 500 watts instead of 200 watts. Still 12 to 60 volts, 10 amps. Next, we're going to take a look at the menu system of the AC500. So if you're familiar with Bluetti's other menu systems, this is going to look very familiar for what they use for the AC200 series and the AC300, and they're continuing on with that with the AC500. So first off, what we have over here is the PV input register. That shows how much power is coming in through the input that is used for the solar panels. So if you have that hooked up to something like an external battery bank instead of solar panels, that's not really showing what's coming in from solar, that's showing what's coming in through that input. Next, we have the grid input, same thing, that's what's coming in through the input that is for grid. In the case of the AC300, that goes directly to a power plug, so unlikely you're running that to anything else. But if you're running off a battery bank with an inverter, then you've got the AC500 hooked up to that, you're going to see your power that's coming in from the grid input. Next, we've got the AC load indicator. That's going to show you how much you're drawing out of the AC inverter. And the DC load indicator. Just like the other Bluettis, we've got the AC buttons down here, AC and DC. You can turn the outputs on and off. Turn it on, turn it off. Turn it on, turn it off, just like you would expect. So one more thing that has been a little confusing in the AC300 that I wanted to figure out how that worked to make sure everybody knows is the color schemes on these icons. So first, let's show you what it looks like here. Each one of these icons has a page that it leads to. Okay, so on PV, I can see how much voltage is coming in from each side and how much power is coming in from each side. So MPPT controller number 1 and MPPT controller number 2. You can see them individually on this screen, so there is a way to do that. On the grid input, I can see the input voltage, the input power, and the input frequency. So if you plug it into a, shall we say, less expensive generator that's putting out very horrible power that is then being rejected by the AC500, you can see that it's out of spec power on this screen, and there'll be a little warning at the bottom. Okay. Next, DC load. You can see each individual circuit, how much power is being put out. So the total DC power, add them all together, 24 volt 10 amp, 12 volt 30 amp, which interestingly, by the way, you can output 30 amps at 12 volts and 24 volts at 10 amps simultaneously, while also maxing out the USB circuits. And yes, there are wireless charging pads on top of the device, as there is for the other larger Bluettis. Okay. The AC load tells you the output voltage, the output power, the output frequency, and the output state, which we're going to talk about in just a moment here. So the output state when the inverter is off is set to stop. Nothing there. Now I'm going to turn on the AC power. See, the grid icon turns yellow. It's not charging because it's at 100%. And my output state is still stop. Now I'm going to turn the AC power, the AC output on. Give it a second to think about it. That icon turned yellow, and then it turned green. So what Bluetti tells me about the color of the AC load icon. So it's green when the AC500 is happy enough with the AC input that's coming into the device to pass that AC input through as AC output. So it basically just means it's happy enough to do that pass through. It does not mean that it is actually passing that through, as you're going to see in a minute. It means it's happy enough to do it. Also, when I take a look here, I have bypass output -D. Okay, so bypass output -D means the grid is in bypass mode and the grid is only supplying power to the load. Basically means it's not charging the battery. Okay, so once I put some load on here, you're going to see I'm going to run the battery down a little bit, and you're going to see it's going to change modes. So next thing I'm going to do is turn on some loads here. And it takes a little bit to run this large inverter down. So give it a second here to spin up. Okay, so my input charging is limited to 12 amps right now. It can charge a lot faster, but the circuit that I have in this room is not set up for that. So you can see I'm pulling about 1400 watts. And I'm outputting about 3,300 watts. So I'm outputting a lot more than I'm pulling, but this icon is still green. Bluetti tells me that that is perfectly normal. It's happy enough with the input power that it could pass that power through, not that it's actually doing so. In this particular case, there's no way for it to pass more power through the device than it can take in, so it's actually running off the inverter right now. If I go in there and check the status, you can see I still have bypass output D. Give it a second or so to run this battery down a little bit, and we shall see. I'll turn off the AC power to have it run down a little faster. Give it about a minute here to get down to about 98%, and you'll actually see that mode change. Okay, but now that I have no grid power connected, you'll see I'm in inverter output. Inverter output means the thing is completely disconnected from power. It's running in an off-grid mode. Now, disconnected from power does not mean that it's disconnected from solar panels. This just means it's disconnected from AC power. Okay, now I'm down to 98%. I'm going to turn it back on. Turn back on my grid. My grid is reconnected. This is going to turn green in a second here, assuming it's happy with it. And it is. But now I'm in bypass output C. So the difference between output C and output D is whether or not it's currently charging the battery. That's it. It's the only difference. There's no magic or mysticism. I don't know why they didn't just label it that way. But the difference between D and C is whether or not the battery is currently charging. So there's our outputs. And yes, it does take quite a bit to get 3,000 watts out of this thing. Let's turn these off. Okay, very good. So now we've got all that set up. So that's what's on this main screen. And also, by the way, if you tap on the center icon, you can now see the state of charge of each independent battery. And yes, there is, in fact, a battery heater in the B300S battery. Yay. This will prevent the battery from getting cold enough to cause the battery to stop working. You will notice that the way that Bluetti did this is they simply changed the operating temperatures. There's no way to interact with the battery heater. It turns on and off on its own. There's nothing you can do about it. And my understanding of the battery heater is that it will only turn on when the battery is powered on, and it draws about 40-ish watts when it's running. That's what I've been told. I actually don't have a cold enough environment to test the battery heater, so I've not tested it. This is just going off their information. You can pick all 6 batteries. You can see the status of each. And you can see I only have one plugged in. So there's your battery status meter. Let's see what else I've got here. I've got the settings. So of course you can change the language. I have an AC output voltage setting. You will probably notice on the retail version that this setting is probably going to be disappearing. On the prototype unit that I have, this setting doesn't do anything. There's a button there, doesn't do anything. I've been told by Bluetti that actually the 100 volt versus 120 volt is an error on this one. The 100 volt unit for the Japanese market is a different physical piece of hardware, and there should not be an option in the menu, so they will probably be removing that option prior to the retail version of the device. AC output frequency, you can change it from 50 to 60, that's going to stay. We still have the PV versus others input selector. This will do PV all the way down to 12 volts if you really want to charge it off a single panel. I don't think that's a particularly good idea on a unit this large. You're going to need quite a bit of solar to keep this thing fed. But if you set it to others, one of the two things it will do is it will limit it to 10 amps. So you'll need PV if you're going to be pulling more than 10 amps, but it does change the algorithm that the MPPT controller is using so that you can have it behave in a way that behaves nicer if you're plugging in external batteries. It's going to be more of a constant type charge as opposed to trying to find that peak power mode. There's an eco mode in here. Similar to other Bluetti devices, what the eco mode does is if you have the AC side of the device on only, in other words, the DC side is off, and the AC output detects that there's no load for more than 4 hours, it will power the device all the way off. So it'll shut it down completely. This does work. You can turn it on, it works fine. One nice thing about the AC500 is it will power back on automatically when the solar comes up the next day. So if you've got a large solar array and you don't need the thing running overnight, you can turn on eco mode. It will automatically turn off at night, and then it will automatically turn back on in the morning. The only thing it does not do is it will not automatically turn the AC output back on when it turns on in the morning. So if you want it to automatically have your AC output back on, you're going to have to do some additional work. But the eco mode does not do that. Machine type, single phase or split phase. We'll get into that in a minute. We have the same UPS mode controls that are in the AC300. So we've got the standard UPS that pretty much it runs it off the grid if there's grid power available. If there's no grid power available, it switches over to its internal inverter. And it does switch over very much fast enough for computers or other electronic devices such as that. Time control, if I turn that on, I can set the time in up to 6 shifts. So when do I want it to charge? When do I want it to not charge? Up to 6 shifts. Okay. I can do the SOC setting, low and high. So high, it will stop charging off the grid and continue charging off PV above this number. So if you only want it to charge to 80% on PV, even with solar plugged in, and you don't want it to charge higher than 80%, this setting isn't going to do that for you. This setting will get you grid to 80%, and then when it's done getting to 80% on grid, it will continue up to 100% on PV. If you want to prevent it from charging to 100% by any means, you will have to put a switch in to disconnect your solar panels to prevent it from getting to 100%. The SOC low will stop giving you power below that battery level. Now, Bluetti devices do hold 10% of the battery in reserve, and we're going to talk about that feature in a minute. But generally, the reserve is in case you have an emergency reserve. I would think most of the time this number is going to be fairly low, because if it ever hits that number, it's going to cut off the AC outputs, and you're just going to have no power coming out of it. So be aware that that's what it's for. It's really for hold some battery in reserve for emergencies. Okay, so now I can go the next mode, PV priority. So PV priority, that's going to reserve a portion of the battery, as you said above, for PV charging only. Exactly the same thing as the high and the low percentage in the previous mode. That's going to basically, it's going to charge from AC until, in this case, it gets to 70%. It's going to reserve 30% for PV charging. That's to save your bill on your power bill. Customized is all of them mixed together. The one thing you can do with customized, you cannot do with the other ones, is you can turn off grid charging entirely. Similar to just unplugging it from the wall, but in this case you don't have to. One other interesting thing, you can turn on and off grid charging from the app if you've got it in customized UPS. Time control status, same as before. You can turn it on and off. If it's disabled, whatever you set in here doesn't do anything. If it's enabled, it does things. SOC setting, that takes effect immediately when you're in customized. Let's go back into standard. Silent mode, it slows down the charging so that the fans don't run. Now in the case of the AC500, the fans don't run all that much anyway. I had a lot of trouble even getting the fans to come on, let alone getting them to stay on any sort of high level. Just the amount of mass that is involved in this device is large enough that even pulling the full 5,000 watts out of this thing, I think I only spun the fan up to medium. Even on a 100% full to 0% dead drain, it's a very quiet solar generator. but they do have a silent mode in case you want to make it even quieter. Max current settings. Let me show you what's in here. There's a basic and an advanced mode. Just like the AC300, you need a password to get into the advanced mode. I will show you what's in there in a moment. So the basic mode, you can set the grid input current anything below 15 amps, which is actually pretty good because the default cable that comes with it, the AC charging cable that comes in the box, it's not safe to draw more than 15 amps over that cable anyway. Most US-based house plugs are 15 amp cables. The way that the US electrical spec is set up, you don't want to have a sustained draw of more than 80% of what the connector is rated for, which means for most houses, you want to set that to 12 amps, unless you've got 20 amp plugs in your house, in which case then you want 15 amps. But you can set it to whatever you'd like there. Okay. Also notice that silent mode overrides this. So if you turn silent mode on, it's going to charge a lot slower than what you set here. Now let's take a look at their password menu, but I cannot show you the password. Okay, so here's the more advanced version of the menu. So you can set the grid input all the way up to 50 amps. Now that requires a cable that can support that much. If you were to set it to 50 amps and you use the cable that comes with the device, you're simply going to blow your circuit breakers. Right? If you wire things up badly, you could have more problems, but mostly you're going to blow circuit breakers if you have this issue. The user-defined button inside underneath the password menu, you can set it all the way up to 50. Okay? And there's one more setting, the max output power. You can force the inverter to run in a mode where it will not output more than 3,000 watts. The reason for this is when the device is first being released, and they may fix this later, but when the device is first being released, they do not have a separate 50 amp split phase device that's coming out with it. So the current split phase device is limited to 3,000 watts per leg, so you actually have to turn the inverter down to 3,000 watts output maximum before you can run the device in split phase mode. And it's got a warning to that effect down here at the bottom of the screen. And that's all that's in that menu. So the only difference between the needs a password menu and the doesn't need a password menu is the fact that you can use a cable that doesn't come with the device in the box. So not too terribly worried about that menu in there. You can get the password from customer service, by the way, after you purchase the device. PV parallel enable. This is the same as PV parallel in the AC300. So if you've got two solar arrays that output the same voltage, they have to be very, very close in voltage. I did not get the exact specs, but pretty darn close. If you turn that on, it will allow one of the two controllers to pull power from both inputs. So you've got two MPPT controllers, you've got two solar inputs. It cross wires both of those. So now both MPPT controllers are hooked up to both solar outputs. So let's say you have one solar array that gives you 100 volts output, and you've got 10 amps on that one. And you've got another solar array that gives you the same 100 volts output, but that solar array is set up so that you have 20 amps. If PV parallel was turned off, one controller would give you 10, the other controller would give you 15, because the controller's maxed out at 15. So you're going to lose 5 amps that you actually technically have enough capacity for. So if you turn PV parallel on, that other 5 amps of available power can now be pulled by the other MPPT controller that didn't have its input saturated by the array that was directly connected to it. So that's what it's there for. You can, in theory, also run two solar arrays to the device using a MC4Y cable. Took the same solar array up to both inputs, but be very, very careful with that. On the AC300s, it's less of an issue. On the AC500, the problem is that the MC4 connectors are only rated for 20 amps, and you can pull 30 amps on this device. So you've got to be real careful not to overload your connectors, or you're going to have hot and or melting wires. So if you are going to use a single run with PV parallel, don't overload it. It's got powerlifting mode, just in case 5,000 watts isn't enough for you. Powerlifting mode is used for resistive loads only. It is not helpful for motors. So if you've got a sump pump that needs more than 5,000 watts, this is not going to help you. This is for things like heaters. This is for stuff that is a purely resisted load, light bulbs, heaters, stuff like that. Okay, this will absolutely destroy your microwave. So I would leave this turned off unless you really have a load that it's specifically needed for. The 5,000 watt inverter is really big. Okay, this is a brand new mode, deep discharge. Bluetti has, in the past, and pretty much always in the past, kept 10% of the battery in reserve. This is why when you see the battery discharge efficiency charts, you never see higher than 90%, because they are not giving you that last 10% of the battery. They're holding it in reserve. Why would they do that? The battery maintenance system, BMS, is running off the battery itself. And the BMS has to be powered in order to safely charge the battery. So you have a problem of how do you power the BMS if the battery itself is not charged. Because the first thing the BMS does when it gets input voltage is it has to check if the input voltage is safe to actually run off of. In order to do that, it can't already be running off the input voltage. You have a chicken and the egg problem. So the BMS runs off the battery, which means if the battery gets to zero, there's no way to recharge the battery. So deep discharge with it off does the same thing as an AC300, same thing as an AC200, same thing all the way back to the original AC200. It holds 10% of the battery in reserve. If you turn it on, you get that extra 10%, but if you get that battery all the way down to zero to the point where the BMS will not turn back on, your battery is now toast. There isn't a good way to recover it. So this option is pretty much for emergency use. You're in the middle of the storm, it cuts off, you absolutely have to have this thing on for another couple of hours. Then you can go in there and turn this on. That's what it's for. It will give you the full capacity of the battery, but it is a risk that it could damage the battery when you do that. They even warn you if you go in there to turn it on. Only available when SOC is 0, so when the SOC is not 0, you can't even turn it on. It will damage the battery pack, and reminder, don't use it unless it's an emergency. So you can't even turn it on unless it's already at 0. You can't just turn it on and leave it on. It won't let you. The buzzer, that's when, same thing as the AC300. When there's an alarm that fires, it makes noise. You can turn it on, turn it off. Touch sound. It's got both Bluetooth and Wi-Fi. You can change the backlight lighting. And by the way, to set which Wi-Fi you're going to connect to. So if you want to set which network, you need to use the mobile app. I have not yet found a way in here to do that. So if I turn it off and turn it on, I don't see a button that has me type in the network name onto this screen. So you're going to have to connect to it via the app with Bluetooth in order to configure which network it's going to connect to. And again, just like the AC300, it's 2.4 gigahertz network only. So you're going to have to make sure your router has 2.4 gigahertz mode enabled because this does not have a 5 gigahertz radio. Next, sleep time. That's how long the screen stays on. I have it set to never just because I'm recording. There was a restore factory settings button, which is going to be real helpful for people that confuse the settings. You can always hit that button. That'll set it back to whatever it was. One other interesting tidbit, if you do connect it to Wi-Fi and you don't reset the settings, it will go online and pull down the current date and time. Very helpful. I'm not entirely sure how it figured out which time zone I'm in. I guess maybe they just guessed. But that's what's in the menus here. So now let's look in the data menu. So first off, we've got the serial number of the device, ARM, the DSP, the HMI. This is a prototype device. Okay, we've got the BMS version of the battery. And again, this is the prototype version that they're running. Input and output. These are the same screens that you get on the main panel. Exactly the same screens. No difference there. Okay. Battery information. You can look at the various state of charge. Again, same as what's on the main screen. And the alarm history. You can see the history of the alarms, when they fired, when they cleared. It's basically the same as other Bluetti devices. Okay. And then there's a dedicated alarm button where you're looking at the same alarm history that was in the previous menu, just a different way of looking at it. So that's what we have here in the menu. Okay, inverter output test. We're going to see how clean the inverter is on the AC500. So I've got my handheld oscilloscope set up right here. And we're going to first plug it into power from the utility. This is my PG&E So it looks like 60 hertz. By the way, it says 16.8 volts because I'm running it through an attenuator so I don't blow up the oscilloscope. So we should see the same voltage, 16.6, because it's going to be the same attenuator when I run it through the inverter. So 60.4, 59. Okay, very good. So first, unplug it from the utility. And we're going to plug this into the inverter. Now this is running in UPS mode when I first turn it on here. AC500 is plugged into wall power, so it should be exactly the same as what's coming from the utility because it's just passing the power straight through, and it is in fact exactly the same. That's what we expect. Very nice. Now I'm going to cut the power coming from the wall. So I'm going to unplug the AC500. See a little bit of a click there as it switches over. And we're still getting pretty much exactly the same voltage. Frequency is a tad bit faster. Let's plug it back into the wall. Give it a second to decide to switch back. And now it's clicked in, it switched back, so this is wall power. And now back onto inverter power. So yeah, I'd say that UPS is nice and fast. That's going to work quite well. Next, we're going to look at the AC output of the AC500 when it's under load. So we're going to do one of the hardest things you can do to an inverter. We're going to turn the inverter on when the loads are already plugged in and turned on. This will be about 3,000 watts of loads. So I'm turning on my AC output. By the way, at this point, the AC500 is powered off. It's not plugged into AC power, and the AC output is off. So now I'm going to turn the AC output on. The loads are already plugged in and turned on, though. See that little bit of a delay as that AC wave comes on. That's what happens when you have that loads already plugged in. It's harder to get that inverter to start. Now we've got just about 3,000 watts coming out of this thing. And we are rock solid. Completely rock solid. I'm going to switch it to turning on the AC input, excuse me. Plug it into the wall. Give it a second to click on. And there is more power coming out of the inverter right now than it can take in from the AC outlet because it's limited on its charging speed. So we're outputting about 3,000 watts and we're taking in about 1,400 watts. So you'll notice that that did not change at all on that AC wave. When I cut the power back off again, simulating a power failure, it's a little bit of a change there, interestingly, but not much at all. We're still at 3,000 watts output. So very good. Now when I turn off some of my loads, see how clean that is. The inverter's still on. The loads are now all turned off. Kick the loads back on. Back up to 3,000 watts. Rock solid AC output wave. This is a very, very nice inverter they have in here. All right, now we've got the DC power stability test. So what we're looking for here is how flat of a line on my oscilloscope does the DC power output. So before we look at the Bluetti AC500, let's take a look at a reference measurement. This is a Astron 50 amp linear power supply. It's known for having very, very stable power, 13.8 volts. You see a little bit of squiggle in the line, a little bit of hash down there at the bottom of it, but that's what a good reading looks like. So that's what we're hoping to get. The AC500 has both a 12 volt and a 24 volt output. So let's try first the 24 volt output. That's going to be a little bit higher up because we've got more voltage, but it should be just as stable. Let's see if it is. And we've connected it. A little bit higher up than where the 12 volt was, but nice and flat. That's a nice, pretty 24 volt output. I like that. Okay, move on to the 12 volt. 12 volt output. This is from the 30 amp connector. Let's plug that in. Oh, well, we happen to have, looks like some AC
portions for our DC wave. This is not very smooth power here. Seems to be smoothing out a little bit, but it's definitely not as flat as the 24 volt. Yeah, we've got some waves in there. So I would probably say the 24 volt, relatively good clean power. The 12 volt, if you're going to be using this for running audio equipment, something like that, you're going to hear some noise on this. It's probably not fast enough for you to notice. Yeah, that's definitely a thing. That's not the cleanest power I've seen.
Okay, let's move on to the last portion of this review video. It is now late August 2022. The previous video was all recorded in July 2022, about a month ago. New developments have happened since then. You can see that this is not live recorded, this is a screencast, because more information is going to make more sense on the screen. Also, I'm not going to be able to put any more pretty pictures up of the AC500 because I don't get to keep it as a reviewer. We have to send them back. It is what it is. So first off, let's take a look at battery efficiency charts. I want to call out that this chart, all the charts that you see in this review took 1,175 hours of testing to generate. That testing time is only the discharge time. That does not include the recharge time. So realistically multiply that by 2. And those numbers include all the different solar generators that I'm going to talk about in this charts. So first off, the AC500 with one battery, they sent it to me with a single battery. So I don't have numbers for more than one battery. The other thing I'm going to call out is I don't have any numbers for the DC side. I just didn't have the time. It took much too long to do the discharge on the large battery, such that I didn't have time to do a DC test, not with all this work on the AC test. My thoughts on that were that this box is really designed for running emergency backup. You're running a small cabin, you're backing up your house, you're backing up your apartment, that type of use case. All of those use cases are primarily AC use cases. So I prioritized the AC graph. I had just barely enough time to finish it and get the rest of the review done before I had to send the device off to the next reviewer because there's very limited numbers of these floating around. So first off, I'll call out that the left side of the chart here, see my mouse moving around, the efficiency is not so great at the low part. That's actually completely normal. Battery efficiency is not a constant. You may hear from certain other reviewers that say the battery efficiency of this unit is blah. That actually doesn't mean anything unless you know where on the load graph that number came from, because battery efficiency is not a constant across the entire graph. At the low numbers, it actually increases the number of hours it takes to run the test such that the idle power becomes the dominating factor of how long it takes to get the thing to run. So your efficiency number goes down because most of your power now is going into just keeping it turned on. Once you get into the point where it's the sweet spot, that's when you get above 80%. In this particular case for the AC500, you get above 80% between 200 and 300 watts. So somewhere in this range right here is where you cross 80%. That's between 200 and 300 watts. At higher than a 200 to 300 watt average load, you're looking at 80% plus efficiency, which is great. That's exactly where it should be. You'll also see at the high end of the graph, and this is true on all solar generators, when you get up to the far end, the efficiency starts going back down. Again, completely normal. The cooling has to kick into high gear. Inverters become much, much less efficient at the very, very top of their rated capacity. Completely normal. So there's nothing weird about this graph. In fact, I'm kind of impressed with how flat it is, because 250 watts all the way up to 4,000 watts, 4,500 watts, we're still above 80% efficiency. This is great, honestly. They did a good job on this. The discharge times at various wattages are in the chart here. So if you want to pause this video and take a good look at that, if you have a constant load, but constant load does not mean what your refrigerator uses when it first kicks on. Constant load means what it uses on average over 24 hours. So most refrigerators, you're probably looking at about 80 watts.
So if I'm going to use this chart to figure out how much a refrigerator uses, it's going to run for between a day 4 hours and 20 hours and 25 minutes, somewhere in that range for a standard household refrigerator running off one battery, which again, pretty awesome. You can run your fridge for a day off a single battery. That's with no power input, by the way. Moving on. So this discharge efficiency graph doesn't make a lot of sense unless I compare it to other things. Let's compare it to the AC200 Max. I don't have an AC300 to compare it to. I didn't buy one. I wasn't doing a lot of review time when it came out. So I don't have one of those to compare to, but I do have an AC200 Max. And this graph also, honestly, I'm pretty impressed with this. So the AC200 Max is more efficient, that's the green line, more efficient at the low end. But I expect that. The efficiency of an inverter at the low end is based off the size of the inverter. If you have a smaller inverter, it's going to be more efficient. Your efficiency graph is basically pushed toward the left of this graph. Okay? So, but it conks out at 2,000 watts, where the AC500 just keeps chugging along all the way to the other side of the screen. So it's doing a good job. You can also see the gray line. That's the AC200 Max with two B230 batteries attached. One thing that I couldn't do, because I only had one B300S battery, was I couldn't do a 6 kilowatt hour AC200 Max setup compared to a 6 kilowatt hour AC500 setup with the same watt hours of batteries for both. So calling out ahead of time these three graphs, these are efficiency graphs. The batteries are not the same across these three units, but actually they track really well. It's, almost like the same design team designed all three devices, which they did. And you can see if you get above, let's see here, 1200 watts average, the AC500 is actually much more efficient than the AC200 Max, because at that point the AC200 Max's cooling starts going into high gear and it starts using a lot of power to run the fans. And then when you start getting above 1500 watts, it uses a lot of power to keep that inverter going. So if you've got higher loads, even instantaneous loads, a well pump, for example, a well pump doesn't use a lot of power very often. Most of the time it's sitting there doing nothing. But when it does run, it uses a lot of power. So if your well pump uses more than 1200 watts when it's running, you're probably going to have better efficiency from an AC500 versus an AC200 Max, even though both of them can actually run the pump. Something to consider. Now let's zoom in on the low end. Yes, comparing an EB3A to an AC500 is a bit absurd. But I just want to call out, the AC500 was not designed for high efficiency at low wattage. People are going to say, oh my goodness, it uses all this power when it's not doing anything. Yeah, that's exactly right. If you're going to run, and by the way, these are all AC numbers, not DC. The EB3A is even more efficient on DC. I don't have DC numbers for the AC500 to compare it to. So if you're running little loads, you're recharging your cell phone, you're recharging a laptop, and for some reason you're doing it off of AC, getting an EB3A to complement an AC500, having a small solar generator in addition to a large one, will improve your overall efficiency dramatically. If we assume for a moment it takes 30% of your power to charge one battery from another battery, and now let's assume for a moment I am running at 25 watts on my EB3A as my load. I'm at 75% versus 30%. So I have 45% power efficiency difference between the EB3A and the AC500. It is more power efficient for me to charge the EB3A from the AC500 and then run my load off the EB3A than it is for me to run the load directly off the AC500. That's how much more efficient it is, which is really cool for the EB3A. Also tells you that the AC500 is really designed to run a house. It's not really designed to charge your cell phone from it. You can do it. I mean, it'll charge a cell phone for days. It'll keep going. I mean, we already got there. AC500 discharge time, 7.5 watts. We're at 2 days and 10 hours. So yeah, it'll charge a cell phone for 2.5 days, but it's not that efficient about it. So different devices for different jobs. Internal power usage. Okay, this is where I take the same graph for efficiency and I flip it on its head. So for efficiency, you take the rated average, the rated capacity of the battery, you take a runtime, and you say, what percentage of the rated capacity did I actually get as output? For efficiency, for internal power usage, you flip that number on its head, and you say, well, whatever power I didn't get must have been used internally. But then you also have to add one more component, is how much of the battery did they set aside that you can't get at? Once you know those numbers, you can calculate the internal power usage. And again, the internal power usage, just like the efficiency, is not a constant. Inverters use a lot more power internally when they are making more power, because the waste energy of an inverter is a function of the total amount of power it's currently generating. So since this isn't a percentage graph, this is a realistic graph, you're going to see the graph moving up and to the right. That's what it does. So you can actually see here the EB3A down at the low end starts using more power internally than the AC500 does when the load gets too high, because it runs into an issue where it hits its cooling maximum. Same thing, the AC200, at a certain point, it starts using more power internally than the AC500 does. I would say the sweet spot for the AC500 appears to be between about 1,000 watts and 2,500 watts, somewhere in there, before it starts going up real high. Now, you can make 5,000 watt loads out of it. You can absolutely do it. And another thing I'll call about this internal power usage graph, because some people are going to point this out also, this is a constant graph. So for 5,000 watts, I started with a full battery. I put a 5,000 watt load on it. I waited for the battery to go to 0, which is the worst case scenario for cooling. Go back to your well pump example. You've got a 2,500 watt well pump, or a 1,500 watt well pump. Well pump only runs for 2 minutes. Fans don't even have to turn on because it doesn't get hot enough inside to turn the fans on. This is worst case scenario. This is that 5,000 watt load is running the entire time, from the time the battery starts until the battery gets to 0. So I'm really pushing this thing hard to see how much cooling I can get out of it. Okay, so these numbers, these internal power number usage, these are worst case scenario numbers. Okay, that's why it's so high over here. But same thing, this is pretty impressive. So the power usage above 1,750 watts is less than what you'd have from an AC200, and the power usage above 200-ish watts is less than an EB3A. So if I've got a 500 watt coffee maker, I could run it from my EB3A, but it's going to be much more efficient for me to run it from my AC500. Okay, that's what you can take away from this graph. Let's zoom in on the low end. So 0 to 500 watts, same data we just looked at. We're just focusing on 0 to 500 watts because this is really where folks that are concerned about efficiency, a lot of those folks, you don't have a lot of appliances that use more than 500 watts. In fact, most residential households, unless you're using a well pump, an electric heater, an air conditioner, those kinds of things, most single appliances, or an electric oven or an electric dry, most of those use cases don't have appliances that use a lot more than 500 watts. So your power usage of the AC500 across this part of the graph is completely flat. Uses about the same amount of power. The cooling doesn't do anything. The generator is perfectly silent. The fans don't even turn on. The thing's got so much internal mass that it has no issue with cooling at these types of levels. The EB3A, it's got cooling problems at these levels. You know, you get above 200 watts and the fans start to kick on high. The inverter efficiency starts going down drastically around 400 watts. AC200 Max is more efficient. Above 100 watts, up to 500 watts, it's winning in this range. But the same thing, it's going to wind up with its cooling turning on every now and then. That's why the graph is not completely flat. Okay? So, right up to about 200 watts here, that's really the number where I decide what I want to run off the EB3A versus the AC500. The AC200, if you've got one of those, it's going to keep going out below the AC500 until about, I seem to remember it was about 1250 watts from the last graph. Okay, moving on. So idle efficiency. The AC500 solar generator, according to my measurements, these numbers do not come from Bluetti. Okay, uses 39.71 watts, or about 40 watts at idle. So if I want to figure out how efficient the inverter is, I want to figure out how many watts of inverter capacity I have per watt of idle power. That will tell me the approximate percentage of how much power am I using to make power. So with this number, bigger number, the number doesn't have a unit, bigger numbers are better. So I have 125.91 watts for the AC500. For the AC200 Max, I have 133.9 watts. So that's effectively the same. There's not a lot of difference there. And this is at idle. So, but going back to our graph there, we're at idle power here, which is, of course, worst case scenario for the percentage of power that's going toward idle. Because when you're not using any power, all of your power is going to idle. Okay? So AC200 Max, AC500, they're about the same inverter efficiency at idle. Of course, the AC500 uses more power raw, but that's because the inverter is more than twice the size. EB3A uses 9 watts at idle. This is, again, assuming the inverter is running. Okay, and these are my measurements, not Bluetti's numbers. Turns out to 69.4 watts of inverter capacity per watt of idle power. So the EB3A has a much smaller inverter. Smaller inverters tend to be less overall efficient. But the nice thing about that inverter is since you're not throwing large loads at it, you don't need that big of an inverter. And it's much more efficient at the low end. So it's just not efficient at all at the high end. So there's the idle efficiency. So you're going to look at the AC500, you're going to say, wow, it uses 40 watts at idle. Well, that's actually not bad because the inverter is gigantic. So break even and max solar panel sizing. So how many solar panels should I buy for my AC500? Am I good with my one single 100 watt Renology panel? Do I just need one panel? Okay, let's figure out how to calculate that. I'm going to use a term called peak sun hours. I'm going to introduce what this is because there are folks who have not heard this before. Peak sun hours is the number of hours at 100% rated solar output of my solar panels that would represent a day, so sun up to sundown, of solar output on a realistic sunny day. So we're not talking laboratory conditions here. Okay, we're not talking peak conditions. We're talking you actually have a real day. Now, we are talking a sunny day. We're not talking cloudy or hazy, okay? But you have a sunny day at a specific location. If I'm in London, my solar profile is going to be drastically different than if I'm in Arizona, which is going to be drastically different than if I'm in Alaska in winter. Humongously different based on where I am on the planet. So in order to know this number, I have to know where I'm at. And then I can get peak sun hours. So a real solar output chart, this is recorded, by the way, from my rooftop solar, looks like this. The vertical axis is how much power I'm making. The horizontal output is what time of day. So at about 8 a.m. or so, the sun starts coming up and I start making a little bit of energy. And about 10 a.m., I'm making a little more. Around noon, it's starting to get up toward the top. Around 2 in the afternoon, it starts going back down. 3 in the afternoon, it's going down. By 8 p.m., it's making nothing. I could calculate how much space there is under this curve. I could. We take calculus, I could do it. I don't really want to. I'd much rather calculate that, which is what peak sun hours gives me. So I can take this peak sun hour number and make my real calculation, which is area under a curve, and turn it into just straight up multiplication because it's easier. Okay. So if I look up peak sun hours, there's a website down at the bottom. There is a group called the National Renewable Energy Laboratory, which in 2018 released a database of peak sun hours for the entire planet. This particular website simply does a lookup based on what zip code I give it and tells me how many peak sun hours I have. Now, that changes during the year. So my average, assuming I lived in San Jose, California, which I don't, but my average would be 5.18 peak sun hours. The maximum is, I think, in July, 8.12. See, that's quite a bit of difference. And my minimum is 2.21. So when you're doing your solar sizing, definitely calculate both the max, the min, and the average. And I'm going to do that on the following slides. You're going to see that. Because the power you generate in winter is going to be very different than the power you generate in summer. And that's pretty much true unless you live on the equator. But moving on. So break even solar sizing. So I'm in a small cabin, I'm in an off-grid situation, I'm in a house that has no power. I want to figure out how much solar panels do I need in order to just keep the inverter turned on. I'm not going to use any power from it, I'm just going to turn it on, leave it on 24/7. Why do I leave it on 24/7? Well, realistically, when you have these types of situations, you have a refrigerator that's got to run. You have other critical loads that you need to have turned on, well pump, sump pump, those types of things. You're generally not turning your inverter off when you go to bed and turning it back on in the morning. Some people do. You can do the calculations based on those numbers if that's what you do. But what you do is you take the solar generator watts, multiply it by the number of hours it's on to get watt hours. So 40 watts times 24 hours is 960 watt hours just to keep the thing turned on. This is a 3 kilowatt hour battery. We're using a third of it every day just to keep the thing turned on. So how much solar do we need to generate back that same power that we just used up? So let's assume it's the middle of winter. We have our 2.21 hours of peak sun. I take 960, which is my watt hours that I need to generate. I divide by my peak sun. I'm going to multiply that by 1.2 because solar charging is not efficient. I actually need to get more power from the solar panels than is going to go into the battery. Okay, you lose about 20% when you do charging. So I'm going to do the 1.2 multiplication. That's going to give me, I need 521 watts of solar. Now that's not watt hours, that's watts. That's how big my panel has to be. So I need 521 watts of solar panels up on my roof in order to break even. That's the dead of winter. So if I'm in the dead of winter and I have a single 100 watt panel, I'm going to be losing power every day. It's not going to keep up. And that's how you do this math. If I have the maximum peak sun hours, same math, I just multiplied by 8.12 instead. So I only now need 141 hours, or excuse me, 141 watts of solar to break even. So in the middle of summer, I could get away with a single 200 watt panel. However, I really don't have any power left. That single 200 watt panel is just to keep the thing running. There's not going to be a lot of power left for me to actually run any of my loads off of the system. A single 100 watt panel, even in the middle of summer, now this is assuming you're in San Jose, even in the middle of summer is not going to keep up. So yeah, don't get your AC500 system and hook it up to a single 100 watt panel and think that's going to be good. You will be unhappy with that. On the average, I need 222.3 watts of solar to break even. So the number of panels that you have at minimum will be somewhere in that range. Kind of depends on whether or not you're worried about winter or not. Me personally, I am worried about winter. I would tend to assume that I would need my backup system at the time of year that is worst suited for solar, because Murphy is alive and well. So I'm going to probably want a minimum of 600 to 800 watts of solar for an AC500 system, bare minimum. Anything less than that, and I'm not going to be happy with the performance of it. Maximum power budget. So let's assume for a moment, again, the AC side is on 24/7. The solar generator can take in 3,000 watts of solar, 1,500 watts times 2. Okay? How many watt hours of energy can I generate for my stuff, my appliances, on a sunny day using the built-in solar controllers? Again, I go back to peak sun hours. I'm going to do the same calculations except in reverse. So I have 3,000 watts coming in. I can get the 3,000 watts for 2.21 hours in the minimum of the year, so middle of winter. And then I subtract out how many watts it takes just to keep the inverter turned on. I come up with 4,344 watt hours of energy, or, by the way, more than one battery holds. So if I want to have a battery charging all day, and I'm in San Jose, and I've got the solar maxed out, I'm going to need at least 2 batteries, at least. Otherwise, that energy that I get during the day is not going to go into the battery. It's going to get wasted because the battery will be full and then I don't get any more power. Okay? If I get the maximum peak sun hours, wow, 18,000 watt hours, which basically means in San Jose, with a 3,000 watt solar array, I can fully recharge from 0 to 100% a 6 battery completely maxed out AC500. Cool. That's actually a very good calculation because it makes sure that Bluetti, when they sized the inverters and they sized the batteries and they sized the MPPT controllers, they're sized in such a way that you can actually recharge it in a single day. And in fact, you can. So that's wonderful. Very happy about that. If you get the average, you can get about 11,500 watt hours of solar panel during the day. So if I'm on average, it's not going to fill up the 16,000 watt hour battery, the fully maxed out system. That's assuming I'm only using the built-in energy controllers. Now, I could do this math again, assuming I'm using all the solar controllers, because each one of these batteries has a 500 watt solar controller on it. Each one of these batteries can also take a DC charging enhancer in addition to the built-in solar controller. And you can use those controllers at the same time concurrently with the built-in controllers. That gives you another 1,000 watts of solar handling per battery. So if you've got one battery, you add another 1,000 watts of solar. If you've got 6 batteries, you're adding another 6,000 watts of solar. I'm not doing that math here because I don't know what the charging limitations are on the AC500 when you max it out that way. I don't know if it's going to be able to accept that much power. Maybe it will, maybe it won't. Bluetti hasn't been forthcoming with the answer. So I'll let you do that math on your own. I would expect, honestly, that it probably can handle it. Because if you think about an AC200 max with 1,000 watts going into it, that's 2 AC adapters. You have a 2,000 watt hour battery being charged at 1,000 watts. And it supports it just fine. Here you'd have a six batteries, so 6,000 watts off the battery, plus another 3,000 watts off the main inverter unit. That gets us up to 9,000 watts. And you have 18,000 watts of battery, or 18,000 watt hours of battery. So again, you're looking at the charging speed in watts is about half of the capacity of the batteries. So yeah, I'm pretty sure it can handle it. I don't have the equipment to test it, so I can't guarantee that it will work. I'd leave it as an exercise to the viewer if you want to redo this math with 9,000s there instead of 3,000s. And yes, I'm going to compare it to a Tesla Powerwall because I actually can. I'm really happy about this. This is the first solar generator that Bluetti has made that is large enough where it is not completely ridiculous to compare it to a Tesla Powerwall. Because the capacity is actually larger. I mean, you can have 18 kilowatt hours of battery, whereas the Powerwall, the Gen 3 Powerwall, the latest one, has 13.5. It's got a bigger battery than a Powerwall. That's pretty cool. In fact, it's got a better battery chemistry than a Powerwall. The Powerwall has an NCM battery. The Bluetti has a LiPo. I like that. Lithium iron phosphate batteries don't tend to start on fire. I'm not a huge fan of putting a battery that might start on fire on the side of my house. It's just me. Cycles to 80%. And I'll get to the inverter size in a minute. But cycles to 80%. Bluetti tells us it's 3,500 plus. Tesla doesn't really want to tell us. They say it's 10 years, unlimited cycles, in quotes. Because if you get below 80% capacity within the 10-year warranty period, they will replace the Powerwall. But they don't tell you what the number of cycles are. And also they replace it with a refurb unit. So yeah, there's that. Pricing. At this time, as of the time of this recording, Bluetti has not yet announced the price for a single standalone B300S battery. They have announced initial pricing on Indiegogo for a AC500 plus a single battery. But we don't know how much the other batteries are going to cost. So in order to do a realistic comparison in pricing to the Powerwall, I'd have to configure an AC500 where the battery size is approximately the same. In other words, 4 or 5 batteries. One of the two. But since I can't currently get a price on that, I left it as question mark. My guess is that Bluetti, and this is just a guess, Bluetti has not told me this information, and I don't mind going out on a limb here. My guess is Bluetti is very hard going to be trying to be price comparative, if not cheaper. Now, I may wind up eating my own words here, but that's my guess. Inverter size, let's jump back up to that. So the inverter on the Bluetti AC500 is 5,000 watts. The Tesla Powerwall is more complicated. It's 5,800 watts, which is about the same when you're on the grid, and it's 10,000 watts when you're on backup. But when you go to wire it to your house, you cannot wire an inverter that's too small to the circuits in your house. The electrical code will not allow it. So even though you can get 10,000 watts out of the inverter of a single Tesla Powerwall, you have to size your transfer switch such that you are only getting 5,800 watts out of it. Because the way a Tesla Powerwall is set up is that the power is running through the Powerwall all the time, even when the power's on. So unless you're extremely creative in how you wire it up, you're really only going to get 5,800 watts out of it. However, this is the one big thing, the AC500 has 120 volt AC power, whereas the Powerwall has 240 volt split phase out of a single Tesla Powerwall. You don't have to buy two of them to get split phase. So that jumps back down to the price question, where the price is a question mark, because if we're really going to compare it to a Powerwall, what I really have to do is configure an AC500 system that has approximately the same number of watt hours of battery, but also gives you split phase power. Because the vast majority of transfer switches, home transfer switches, require split phase power in order to hook the generator up to the house. The thing I really like about the AC500, by the way, is the fact that it's removable. The sales model here is where I think Bluetti is going to kick butt. In fact, I think long term, this is going to wind up being the way it's going to work. If you live in an apartment, you can't buy a Powerwall because your landlord is not going to let you install one. Well, I mean, they probably let you, but then they keep it. You can't just take it off the building and take it with you when you leave. So it's not useful for the most of Americans that don't live in single-family homes. However, Bluetti, very smartly, I think, you can buy one and you don't really have to hook it up to your house. Yeah, the extension cord jungle is not the best, but if you live in an apartment, it's way better than not having anything. And there's a lot of places where you can live where you can't easily have a gas generator, and they have that market open to them. So that's great. You know, even if you do live in a single family home, if you move while the batteries are still good, you can just pick them up, take them with you, take them to the next house. Putting in a transfer switch is way less expensive than putting in a Powerwall. And besides the fact that Tesla won't even install a Powerwall unless you have solar on your device, or on your house, excuse me. So you don't have to reinstall all of that every time you move, which is great. So I call it removable, not so much portable. The batteries are 100 pounds each. The main unit is, I think, 88 pounds. So yeah, it's not something you're going to want to take with you down to the local sporting game. It's not something you're going to want to take with you to the park. But if you've got to move it, you can. It's not permanently affixed to the side of the building, which is awesome. So conclusions. Again, the live portion of this review was recorded a month ago. So my conclusion reel that I made then is no longer current. So what do I like about it? It's large enough where I can make a comparison to a Powerwall, really, and the installation process. It's much easier to put into your house. There's much less contractor required. The solar contractors out there are going to hate that, but you don't need as much work done by a contractor. The inverter wattage and the battery storage was upgraded. Even though it's larger, it's somehow just as efficient about-ish as the AC200 Max. You saw those efficiency curves were very, very similar. And in the mid-range part of the efficiency curve, it's exactly the same, which is great. What do I like? The battery heater. In case you guys didn't catch that earlier, there is a heater in the battery, which is great. By the way, earlier there was a voiceover error there. It's 350 watts for the battery heater, not 50 watts, 350 watts. It turns on and off on its own whenever it feels like it. But yeah, that means that if it starts getting really, really cold outside, the battery heater will kick on and you won't just lose power. So yay, that's awesome. Finally, very happy with that. Compatibility with the B300, the current generation batteries, and even mixed generation batteries. If you only put 4 batteries on an AC500, you can have some number of them. You can have 3 of them be the current generation B300 batteries and 1 of them be the B300S. Cool. That's much better than I was expecting. So mixed generation batteries, awesome. What could they do better? Connection between existing grid-tied solar and the AC500. If you've got microinverters on solar panels that are already installed on your roof, there's nothing you can do. Those solar panels are never going to talk to an AC500 pending any device that Bluetti releases in the future. They don't charge off AC from microinverters. Not much you can do there. If you have non-microinverter systems, so you've got a 400 volt DC system sitting up on your rooftop, there is, in theory, a device called the PV voltage step-down module, which would allow the Bluetti to charge off of a 400 volt standard residential solar install. However, that device has been unavailable for at least 3 months. Maybe it'll be back in stock eventually, but as long as that's out, as far as I can tell, there is no other company that makes a device like that, which is probably why it's out of stock, because they probably have a lot of custom work that goes into that. But until that comes back in, there's no way to hook it up. And there's no communication with existing home inverters. So I cannot say, for example, have the AC500 make a call into my existing home inverter and say, hey, how much power is coming in from the solar panels? I want to make sure I don't charge any faster than that. It'd be a nice feature, but they can't do it right now. And I do understand that IoT communication is very challenging across vendors. They could at least have a sensor that I could put in my main panel that would be able to tell me how much power my house is using, how much am I sending back to the power company. They could release some sensors that would do that to make it a little smarter. Next, code compliance. So if you're in a state that complies with the 2017 version of the National Electrical Code instead of the 2014 version, they require you to have a button or a switch or something near your main panel such that it does two things. One, it has to de-energize the solar array, and two, it has to turn off the inverter. De-energizing the solar array, that's pretty easy. $130 box they sell on Amazon, flip the switch, turns off the solar array. Everything's de-energized. Pretty easy to get a rapid shutdown for the solar array on a Bluetti system. The second half is much harder though. Unfortunately, there isn't a good way to disable the inverter in the Bluetti based on some button that you put on the outside of your building. What they would require is a Bluetooth command effectively to come into the device, which those buttons don't tend to get pressed unless the building's on fire. So I would really want a physical wire to make that work. So that's going to be an issue for folks that live in states that require the 2017 plus version of the National Electrical Code. That's assuming you're getting installed in the building, hard installed, and you're using a contractor that is going to require code compliance. But that's something that I think Bluetti really should address in future versions of the device. The 12 volt power could be more stable. Honestly, it's not that big of a deal. The power fluctuations were so slow that if you've got a camping refrigerator, if you've got lights in your camper, these fluctuations are so slow that you're not going to notice. You're talking about a quarter of a volt bumping up and down every 500 milliseconds. You're not going to notice. There's no device that you bring with that's not super sensitive that's going to even care about that. That said, it was probably a pretty simple fix at the circuit level to make it not do that. So it's something they really should address. Until they address it, I probably wouldn't recommend running highly sensitive laboratory equipment off of the 12 volt output on the Bluetti. You probably don't want to run your oscilloscope off of it, assuming you have one. You probably don't want to run a DC load tester's input voltage off of it. You don't want to run a reference 12 volt input on it. A ham radio, some of them might care. The ones in the higher frequency ranges might care. Your HF ham radio, you might hear a little warbling on it, but probably it's not going to care. So really, this is more of a testing issue that they could have cleaned up as opposed to a realistic problem that people are going to run into. But they could have made it a little bit cleaner. Data logging, this has been being asked for by everybody for a year plus. Since the AC300 came out, can it log how much power I'm using over a day? Can it log how much solar energy is coming in over a day? Can I see the kinds of solar energy graphs that I showed earlier in the presentation? Charts and graphs, those kinds of things. It doesn't do any of that. It'd be nice to have it. 220 volt split phase at this size of device really should be in a single unit. In fact, they've even got a couple of power outputs that have 4 prongs. It would be nice to have it in there. Now, of course, the trade-off would be that there'd be 2 inverters to make that work. and both inverters would have to be smaller. So to make it fit in the same size box and to have two inverters, you're going to have to make some components smaller, which means both inverters in that case would have to be half the size. I'd probably be okay with that. I don't know if everybody would be, but that would be my preference. Just because of the size of this unit. US spec is split phase. Now that would make it much more complicated for Bluetti and probably make the device more expensive, because the US runs on split phase, but a lot of the world does not run on split phase and wouldn't need a second inverter. They're going to have to be really creative if they don't want to have two completely different architectures, one for the US and one for everything else, if they were going to do it that way. Probably the reason they did it the way they did. But again, it'd be nice to have it in a single box. Questions I have for the future: battery replacement. 10 years from now, am I going to want to use the same head unit? Am I going to be able to get another battery that plugs into an AC500 when the batteries expire? Or will technology have advanced so much that the units 10 years from now are so much better that I just don't care and I want to upgrade? I'm not sure about that one. Cable management. This is another one to call out. Let's say you're in a second floor apartment and you want to set up a 6 battery system with an AC500 head unit just as a backup system to keep yourself up and running. Let's say you've got some medical equipment that uses a bunch of power and you absolutely do not want to have no power. Well, the problem is the batteries are 100 pounds each. The head unit's 88 pounds. You cannot put 700 pounds on a second story floor in an apartment all in one place. You have to spread out the load. The floor probably isn't going to take it if you do that. Depends on your building, depends on how it was made. Some will take it, some won't. Longer battery cables, 10-foot, 15-foot battery cables would completely fix that. It'd be really nice to have long battery cables. But that's kind of a nit, because the system in general works. And I don't know how many people need the longer battery cables. I would like them. But I don't know for sure that everybody needs them. So that's what could be better. So thank you all for watching the video all the way to the end. I can be a bit long-winded. Let me call out already, I am not a paid reviewer. I don't get any money for this. I don't make money off of the solar generator industry. I'm in a completely different industry. I do this because it's fun. Takes a bunch of work to do it. I don't really get much out of it. I didn't get to keep the solar generator. I had to send it back. I was reimbursed for my cost of sending it back, so I'm not out money for reviewing it, but it's not the big money industry here. I don't make money off advertising. I don't make money off affiliate codes. I do it because it's fun. And as long as I keep having fun doing this, I'll keep doing it. So if you guys enjoy watching it, let me know you enjoyed it. If everybody enjoys it, it'll make me feel warm and fuzzy, and I'll probably make another one. So thank you all for watching.